The U.S. Navy continues to be at the forefront of technological innovation in the world of modern naval warfare. With a wide range of the latest weapons at its disposal, the U.S. Navy is a formidable force capable of projecting its influence anywhere in the world. From railguns that use electromagnetic energy to accelerate projectiles, to powerful weaponized lasers that can burn through targets miles away. Get ready to see the incredible firepower of the U.S. Navy. The best U.S. military engineers are working tirelessly to turn the most fantastic ideas into reality. One of these is the U.S. Navy railgun. In 2005, development began on the EMRG, or electromagnetic railgun, a revolutionary electromagnetic weapon that fires projectiles at over 7,500 miles per hour, or about Mach 10, 10 times the speed of sound. The railgun is radically different from other conventional guns, cannons, or howitzers. After all, these all rely on the pressure of an ignited power charge to push the projectile out of the barrel, sending it flying along a ballistic trajectory. The railgun uses electricity and magnetism instead of gunpowder and chemical energy to accelerate a projectile insanely along a pair of rails. This makes the system not only more deadly, but also technically safer. The shells are much faster, much cheaper, and the amount of explosives stored in the bowels of the ship is reduced to a minimum. The most suitable ships for a railgun are the Zumwalt-class destroyers, due to the most powerful Rolls-Royce turbogenerators capable of producing 78 megawatts of energy, which is enough to operate such a greedy gun. The U.S. Navy planned to increase the range of the railgun from 100 to 230 miles, with a destruction efficiency of 64 megajoules. However, the gun of the future fell victim to the so-called hypersonic trend. After 15 years and $500 million spent building the railgun, the U.S. Navy has decided to put the project on hold, shifting its focus, budgets, and efforts to hypersonic missiles and combat lasers. The latter, by the way, have already been showing excellent results. The U.S. Navy has several advanced combat laser designs at its disposal that could change the balance of battlefields in the coming decades. Let's take a closer look at them. Solid-state laser technology maturations, or SSLTM, is a program to create a shipborne laser weapon system demonstrator, or LWSD, with a beam power of up to 150 kilowatts, capable of providing increased effectiveness against small enemy boats and UAVs. LWSD is the result of the U.S. Navy's past experience with the AN/SEQ-3, or the XN-1 Laws ship protection system from the notorious Northrop Grumman. The AN/SEQ-3 became the Navy's first operational laser and was successfully installed on the Austin-class USS Ponce, or LPD-15 amphibious transport dock, which later became a test site for a naval base in the Middle East. But SSLTM will be much more powerful, providing a 150 kilowatt beam of directed energy instead of the 30 kilowatt offered by its predecessor. Unlike LWSD, Optical Dazzling Interdictor, Navy, also known as Odin, is not so much a laser weapon with a power of hundreds of kilowatts, but a cunning deactivator of enemy drones. Instead of destroying drones with a beam, Odin disables their electronic sensors, causing them to lose their target, go astray, and eventually just fall. This type of laser is ideal for surface warships such as cruisers and destroyers. Today, according to the U.S. Air Force report to Congress for December of 2022, Odin systems are already on 8 Arleigh Burke destroyers. The high-energy laser with integrated optical dazzler and surveillance, or Helios, provides the Navy with fundamental new opportunities by mixing the two previous technologies, a combat laser and a UAV dazzler. In official documents, this weapon is also listed under the name Surface Navy Laser Weapon System, or SNLWS, Increment 1. This time, a 60 kilowatt combat laser capable of destroying small boats and drones, as well as blinding them at a distance of up to 5 miles, was set on the USS Preble. At the same time, when the laser sensors are not focused on attacking a specific target, they can be used for a secondary role of observation. Due to the scalable architecture of the Helios design, the 60 kilowatt limit can be more than doubled, up to 150 kilowatts. But with a 150 kilowatt laser, shooting down enemy hypersonic missiles won't be so easy. This is where HELCAP, or High Energy Laser Counter ASCM program, comes in, being a flexible prototype system for government experiments and demonstrations of high-energy combat lasers capable of hitting anti-ship cruise missiles, and in the foreseeable future, even hypersonic weapons. The key element of this system is a 300 kilowatt laser. HELCAP is designed to solve the problems with most modern enemy missiles, taking into account such important factors in their destruction as atmospheric turbulence, automatic identification of targets, and selection of the aiming point, as well as accurate target tracking with low jitter in conditions of strong interference. Additionally, engineers have been working regularly on improved HELCAP beam control and developing options for higher power, up to 1 megawatt. But the most important thing that cannot be taken away from lasers is the cost of the projectile. After all, they are practically free in comparison with other newest weapons of the Navy. We are talking about hypersonic missiles, another important building block in the foundation of the power of the American fleet for the coming decades. The Long-Range Hypersonic Weapon, or LRHW, under the formidable nickname Dark Eagle, is a medium-range hypersonic ground-to-ground weapon being developed for the U.S. Army. The weapon consists of a large rocket booster carrying an unpowered hypersonic glider, or Common Hypersonic Glide Body (CHGB), in its nose cone. When the booster reaches the required altitude and speed, it releases the CHGB, which, as it descends, glides at hypersonic speed towards the enemy target. The cost of one such toy comes out to be a whopping $41 million. The operating range being about 1,725 miles, and the speed declared by the Pentagon reaching an impressive Mach 17. The main contenders for the LRHW installation are the previously mentioned Zumwalt destroyers and the Virginia Block 5 submarines. The second, but by no means least, U.S. Navy program in the field of hypersonic weapons is called Offensive Anti-Surface Warfare Weapon Increment 2, or OAS-UW. However, today it's better known as HALO. Hypersonic Air-Launched OAS-UW. Interestingly enough, in the budget documents submitted to the Navy, it was specifically this service that described it as a national imperative for the development of hypersonic capabilities. HALO is a high-speed, long-range air launch system that provides superior anti-surface warfare capabilities. This weapon will address advanced threats from engagement distances that allow the Navy to operate in and control contested battle space in littoral waters and anti-access area denial, or A2AD, environments, and the main platforms for it could be the fleet of U.S. Navy F/A-18s and U.S. Air Force B-1B bombers. It's good that despite the active development of hypersonic missiles, the U.S. Navy hasn't forgotten about the modernization of those that have already served the fleet for decades. For example, the Tomahawk. This is one of the oldest and at the same time, the most effective missiles in U.S. service. It was created by the General Dynamics team in the 1970s and very soon became the main cruise missile of the fleet, proving its right to lead in the Gulf War, dozens of military operations in Iraq, Afghanistan, Libya, Yemen, and Syria. Over the past 32 years, the U.S. military has used about 2,200 of these missiles of various modifications during conflicts. And as of 2020, the U.S. Navy possessed about 4,000 Tomahawks, deploying about 10,000 launchers for them. Since its inception, at least 6 variants and several upgraded versions of these missiles have been developed, including air, submarine, and land-based conventional and nuclear weapons. Engineers chose a liquid-fueled turbojet engine for rockets because of its ability to provide greater range than a rocket engine of the same size. The lower speed also makes flying at low altitude more viable, making it even harder for the Tomahawk to be detected by enemy radar. The latest Block 5 variant has added upgraded navigation and communications equipment to the older Tomahawk, with electronics that make it as easy as can be to work with electronic warfare and make it difficult for enemy radars to detect. This is extremely important because, once detected, subsonic cruise missiles are relatively easy to shoot down. The Block 5A Maritime Sea Tomahawk, or MST, allows the missile to successfully hit moving sea targets, and the Block 5B with the JMEWS, or Joint Multi-Effects Warhead System warhead, can effectively hit even the hardest targets. The upgrade was so successful that it was decided to convert all Tomahawk Block 4s to Block 5, while the remaining Block 3 missiles would be decommissioned and demilitarized. Modern missile cruisers of the Navy carry 122 launchers, and destroyers from 90 to 96 launchers. Although the concept of the Tomahawk is already slightly outdated, its ability to keep up with the times and adapt to future threats makes it one of the most powerful weapons in the Navy's arsenal for decades to come. Speaking of missiles, one cannot fail to mention the legendary Submarine-Launched Ballistic Missile, or SLBM, of the Trident family, UGM-133A Trident II, or Trident D5. First deployed in March of 1990, these weapons are still a nightmare for all U.S. enemies. Trident is a key element of the U.S. strategic nuclear triad and a reliable sea-based system capable of hitting multiple targets. Trident II missiles with a maximum speed of Mach 24 and an operating range of 7,500 miles carry 14 U.S. Ohio-class submarines of 24 each. Due to the increased payload of Trident II, nuclear deterrents can be carried out with fewer submarines, and its high accuracy, approaching the accuracy of ground-based missiles, allows the missiles to be used as a first strike weapon. In 2002, the U.S. Navy announced plans to extend the service life of submarines with D5 missiles until 2040, forming the D5 Life Extension Program, or D5 LEP, which later received logical development as part of D5 LE2. Almost 20 years later, in 2020, it appeared reports that the first D5 LE2 missiles would be deployed aboard the 9th Columbia-class submarine in fiscal year 2039, and that their service life was going to be extended until 2084. Another major achievement in the field of missile defense of the U.S. Navy was the SM-3, a short to medium-range ballistic missile interceptor as part of the Aegis system. In addition to this function, the SM-3 has proven itself even as an anti-space, anti-satellite weapon. Thus, a modified version of this missile, launched from a group of 3 ships in the North Pacific Ocean in February 2008, successfully destroyed the failed U.S. satellite USA-193 at an altitude of 130 nautical miles, shortly before its re-entry into the atmosphere. Moreover, the weapon's software was heavily modified to increase the chances of the SM-3 sensors to recognize the satellite as their target, since the missile had never been used for anti-satellite operations before. The SM-3 Block 2A update by Raytheon and Mitsubishi Heavy Industries has made the weapon even more agile and equipped with the latest sensors to help the SM-3 deal with most enemy ICBMs. The development of Block 2A will help the United States protect, among other things, its closest allies, giving Japan a reliable military standing in the event of an attack by North Korea or other friendly neighbors. Among other missiles, there are the AIM-120 ARAM, or Advanced Medium-Range Air-to-Air Missile, AGM-88 HARM, High-Speed Anti-Radiation Missile, and JDAM, or Joint Direct Attack Smart Bombs munition, equipped within the U.S. Navy fleet. These missiles allow you to destroy targets in all weather conditions, disable enemy vehicles and advanced radar systems, and receive regular updates to improve their accuracy, operating range, and overall lethality. After all, what are these ships without torpedoes? Here, confidence is again boosted by the heavy torpedoes Mk-48 and light torpedoes Mk-50. The main task of Mk-48 is to destroy enemy nuclear submarines and its high-performance surface ships. Since its introduction into service with the U.S. Navy in the 1970s, the Mk-48 has come down a long and thorny path. Its latest modification of heavy torpedoes will be quieter, have an improved propulsion system, be more resistant to electronic countermeasure systems, and receive the latest Common Broadband Advanced Sonar System, or CBASS guidance system, which will allow it to fix itself onto enemy ships even at greater distances. The Mk-50 will also help the Navy in the fight against fast deep-sea enemy submarines. It can be used from all anti-submarine aircraft and torpedo tubes of surface warships. When it was created, great attention was paid to chemical interaction. For example, the Mk-50 propulsion system with a small tank of gaseous sulfur hexafluoride provides this system with a huge advantage in working at great depths. Since the products of combustion, sulfur and lithium fluoride, occupy a smaller volume than the reagents, the torpedo does not need to displace them due to the increasing water pressure when approaching an enemy deep-sea submarine. And finally, let's not forget about the U.S. Navy's melee weapon systems. The Phalanx Close-In Weapon System, or CIWS, is one of the most advanced automatic protection systems for military watercraft against enemy aircraft, missiles, and small boats, designed, among other things, to become the last line of defense against anti-ship missiles. Due to its distinctive barrel-shaped fairing and automated nature of operation, this weapon was quickly nicknamed the R2-D2, after the droid of the same name from the Star Wars movies. The system consists of a 20mm six-barreled M61 Vulcan Gatling gun with radar guidance in the Ku-band radar space, and FLIR to detect and track incoming targets mounted on a swivel base. In addition to the standard version, the U.S. Navy also uses CRAM, combining RIM-161 rolling airframe missiles and phalanx-based sensors. The main difference between the version for the fleet was the use of tungsten armor-piercing shells in the M61. Well, where would the U.S. Army be without the legendary M2 Browning, a heavy machine gun developed by John Browning at the end of World War I. Due to regular upgrades, these weapons are still ready to fight back against all enemies of democracy. The M2 has taken part in countless military conflicts around the globe, and excelled in the fight against unarmored or lightly armored vehicles, boats, light fortifications, and helicopters. Despite its venerable age, 90 years old, it received an upgrade to the M2A1 version in 2010, and the very next year it was named one of the greatest Army inventions of 2011, which sounds a little ironic given the date the gun began to operate. Formerly known as the M2E2, the M2A1 incorporates improvements to the design, including a quick-change barrel, or QCB, with a removable carrying handle, a new slotted flash suppressor that reduces muzzle flash by 95%, fixed headspace and timing, a modified bolt, and a manual trigger block safety. As you can see, the U.S. Navy is very good at adapting to both the latest threats, most of which we'll be seeing only in the next 20 years, and to older enemy approaches. Which of these weapons impressed you the most, and why? Let us know in the comments below. And if you enjoyed the video, please leave a like, subscribe to the channel, and hit that notification bell for more content like today's. Thanks for watching, and we'll see you in the next one.